Maybe everything you think is real isn't.
Mm.
Maybe the ground you stand on, the air you breathe, even your own thoughts are just, well, one version of things. Or maybe not even things at all, but something far, far weirder. Welcome to the cool, weird, and possible.
Today, we're really jumping into the deep end. We're going to explore some scientific theories that seriously challenge our basic understanding of reality.
And these aren't just sci-fi ideas, right? These are from actual physicists.
Exactly. Straight from the minds of physicists trying to figure out how the universe actually works. And let me tell you, they get pretty wild. Fascinatingly strange.
Okay, let's really get into this then. Where do we even start trying to shatter reality? Maybe right at the bottom. Like, what is stuff made of?
Good place to start. So we talk about particles, right? Electrons, quarks.
Yeah, like tiny little balls, little marbles buzzing around. That's how I always pictured them.
That's the intuitive picture, yeah. But the science, it tells a different story. When physicists actually try to look at what a particle is, fundamentally...
They see the tiny marble.
No, that's the thing. They don't. Sources we looked at point out we don't actually know what they look like. You don't see a point. You just see this blurry sphere of influence. A region where something is happening.
Wait. So the basic building blocks?
Yeah.
The things that make up, well, me.
Yeah.
We can't even picture them. Just a fuzz.
Pretty much. A fuzzy effect.
That's the first crack in my reality right there. How do scientists even do physics then, if they can't see or picture the very things they're studying?
Well, one way they handle it, as one source puts it, is through a kind of necessary fiction.
A fiction.
Yeah, they invented a story, basically, a mathematical tool. They just pretend the particle is a single point in space.
Seriously?
They'd pretend.
For the math, yes. An electron is treated like a point with a certain charge, a certain mass, even though they're pretty sure it's not actually a point in, physical space. It's a mathematical fiction, as the source called it. Made up so the calculations work. A mathematical fiction? That sounds suspiciously like they just made up a story so the numbers would add up, like a convenient narrative.
Well, you could see it that way. It definitely highlights how our mathematical descriptions are amazing for prediction, but they don't always give us a literal picture of what is.
Yeah.
And this whole idea of useful stories or frameworks, it goes further, like string theory.
Oh, yeah. Heard of that. Theory of everything, right?
No, maybe. It's an incredibly valuable tool for theorists, helps them discover things about the quantum world, beautiful math. But it might also just be another useful story, not necessarily the final answer. We use these models because they work, mathematically speaking, even if visualizing them is tricky.
Okay, so particles aren't tiny balls. They're maybe fuzzy zones of influence, and we pretend they're points for math. What else could they be, though? Is there another way to think about them?
Oh, yes. There are definitely other ideas. Some theories suggest that maybe reality at the bottom isn't made of points at all, but is more continuous, like a wave field, or even a kind of abstract fluid spread out in 3D space.
The fluid, like water.
More abstract than that. But yeah, conceptually. One source talks about the wave function. That's the math describing a quantum system, not as something happening in some weird higher dimension, but as a function of many points right here in our normal 3D space.
Okay.
So imagine reality as this, let's call it a fluid. And within this fluid, what we think of as particles, those little balls, they're just approximations, or maybe complex patterns that emerge from how the underlying wave, the fluid, behaves.
Like ripples or eddies in the fluid.
Exactly, that kind of picture. It actually helps visualize some quantum stuff, like how a particle's path can spread out like a wave if you don't disturb it. But then if it interacts with something, it gets sort of refocused into a definite spot, kind of like light going through a lens.
So the solid little things I imagine making up my chair, my desk, even me, they aren't really real like that. They're just fictions or math tricks or patterns in some quantum goop.
Goop might be pushing it, but yes, something wavier, fuzzier, less defined than we usually think.
Okay, here's where it gets really weird for me then. If the bits I'm made of aren't solid, defined points, what does that mean for me? Am I just a complex pattern in the goop? Does my sense of being a distinct person even hold up?
That's a really deep question. If the fundamental reality isn't localized things, but spread out fields or waves, yeah, our classical ideas about identity, about boundaries, they start to get fuzzy. And that thought, it leads us right into maybe the most famously mind-bending quantum idea.
Don't tell me. Many worlds.
You got it, the many worlds interpretation.
This one always felt like pure science fiction, but it's real physics.
Oh, absolutely. Proposed by Hugh Everett back in the day. The core idea is whenever a quantum measurement happens, right, and there are multiple possible outcomes, like an electron spin could be up or it could be down.
Yeah. One of them happens, right?
Well, according to many worlds,
Right.
no, all of the possibilities actually happen. The universe doesn't just pick one. It branches. It splits, creating parallel universes, parallel worlds, each one representing a different outcome.
Whoa, hold on. Every single time, every quantum event with choices,
Whoa.
the whole universe splits. So like if I hesitate choosing coffee or tea,
Yep.
the universe splits. There's a reality where I had coffee and another one where I had tea. Right now, infinite Ms living infinite lives.
That is the radical implication, yes. The theory uses something called decoherence to explain why these branches become separate. They diverge, become autonomous, they don't interact, which is why we, stuck in one branch, only experience one reality. We don't see the others.
Okay. My brain is starting to hurt.
Mm-hmm.
But, okay, if every outcome happens in some universe, what does probability even mean then? If I have a 50% chance of drinking coffee, but I do drink coffee in one universe and do drink tea in another,
Yeah.
the probability was 100% for both, across all the worlds. That doesn't make sense.
Right. That question about probability, it's actually a major conceptual hurdle for many worlds. One source really highlighted this. If everything happens, what does probability even signify?
Yeah.
Proponents have ways of tackling it, often talking about the measure or weight of the branches in the overall wave function, trying to recover the probabilities we observe. But yeah, it forces you to rethink what likelihood fundamentally means.
I saw something about using set theory, like the universe is a set, branches or subsets. Did that help?
It's one way to frame it. It shifts the perspective. Instead of thinking you're in one specific world,
Uh-huh.
this view suggests an observer isn't in just one world. The observer kind of inhabits the whole set of
The
worlds.
set of worlds. So I'm not just me here now. I'm
Kind
the collection of all the mens
of.
across all the realities simultaneously.
In that specific framework, yes. You'd have multiple elemental bodies, basically versions of you, in different elemental universes, the branches. Each electron in your body in one elemental universe might be spin up, but the overall electron state you'd consider before measurement includes both possibilities across the whole set. It's deeply counterintuitive for our sense of self.
Elemental bodies. Inhabits the set of worlds. Okay, that is seriously messing with my head now.
Yeah.
Am I having this conversation? Or is another me having a slightly different one and another me just ordered pizza
Yeah.
all at once? My sense of being one person is just dissolving.
It definitely throws our everyday notion of a single self and a single reality out the window. It suggests our experience might just be one slice of something vastly bigger and weirder.
Okay, if the universe is splitting
Yeah.
and I'm maybe spread across all these worlds,
Yeah.
does my viewpoint matter more? Does my perspective shape things?
Well, some interpretations take the observer's role even further than many worlds.
Oh, great. What now?
There's an idea called the consciousness-only solution, or a console. One source described it as purely perspectival,
Perspective all.
meaning there's no single, objective, absolute reality out there for everyone. No global view. Everything is relative to one unique observer.
One unique observer. So my reality is built just for me. What about you? Is your reality totally different?
According to Console, fundamentally, yes. The math, the state vectors, the properties of things, they only have meaning relative to a specific observer. It actually deals neatly with certain paradoxes, like Wigner's friend, where different observers seem to see different things. Console says, yeah, they do. And you can't compare them from some outside objective viewpoint because, well, that viewpoint doesn't exist. Your reality is for you, mine is for me.
So my consciousness, or just me looking at something, literally defines my version of the universe, and yours defines yours. That feels incredibly self-centered. Are we even in the same universe talking?
It definitely shifts the focus from a shared stage to a collection of individual viewpoints, and it does something even weirder with time.
Oh, no. Don't tell me time gets weird, too.
It suggests past events aren't necessarily fixed. They can remain undetermined, just possibilities relative to you, until a measurement now connects them to the branch you're on.
Wait. Undetermined past.
Yeah, and when you make that measurement, that connection, the past event becomes definite, but not just from now on. It becomes definite retroactively, right back to the moment it was supposed to have happened.
So measuring something now could change what actually happened yesterday or last week. Okay, head officially hurts. But that's wilder than any conspiracy theory. The past isn't fixed. It's fluid until I look.
Within that framework, from your perspective, yes. Your present observations crystallize your past. It echoes that local fluid theory, too, which also emphasizes the observer and their past light cone.
Right, the light
Had
cone, all the info that's had time to reach me.
Exactly. Your world, in that view, doesn't contain results from distant galaxies until the light, the signal, actually gets to you. Reality is built up, moment by moment, from the information that arrives at your location for your perspective.
Wow. So my perspective, my consciousness maybe, is literally constructing my personal universe from incoming data feeds.
As
That's, yeah, intense and kind of lonely, maybe.
It does paint a very personalized picture of existence, definitely,
Yeah.
less universally shared.
Okay, speaking of information arriving,
Yeah.
let's talk entanglement, the EPR experiment. Einstein's spooky action at a distance. That's got to fit in here.
Ah, yes, the classic weirdness. Two particles linked quantumly, then separated by miles or light years, whatever.
Yeah.
You measure one, say its spin, and instantly you know the spin of the other one, no matter how far away it is.
Instantly. That's the bit that gets me. If measuring particle A changes its state, and particle B's state is known instantly,
Mm.
isn't that information or something traveling faster than light, violating relativity? Spooky.
It looks like it, doesn't it? The
Yeah.
standard explanation is, well, it's just correlation, not causation. You
Yeah.
can't use it to send a deliberate message faster than light because the outcome of your measurement is random. You can't force it to be spin up to send a 1. So no FTL communication.
Okay, yeah, I've heard that. But one source pushed back on that, didn't it? So correlation usually implies a common cause, but Bell's theorem rules that out for entanglement. So if it's not random chance and not a common cause, what is it?
And that's where the interpretations really clash. It's still hotly debated. The source gave this really striking example. Alice on Earth, Bob, way out in Andromeda, billions of light years apart. They have entangled particles.
Okay.
They could perform the exact same action, push a button, don't push a button at the very same instant based purely on the random outcome of their measurement. Alice measures, gets up, pushes the button. She knows instantly Bob got down and didn't push his button.
Yeah.
They synchronized actions across billions of light years.
Whoa. So even if they can't send like a text message saying push the button, the information about the outcome is shared instantly, allowing perfect synchronization. That's like the ultimate secret cosmic handshake. It glows locality right out of the water.
It certainly suggests a deeper connection, yeah.
Mm.
Something non-local woven into reality. Though even things like quantum teleportation, which looks like magic, transferring a state instantly.
Yeah, that sounds like magic too.
Well, some analyses show you can explain it locally within certain mathematical pictures, like the Heisenberg picture. It makes it seem less like a conjuring trick, showing how the information gets there without necessarily needing instantaneous influence. It's complex, but they're working on it.
Okay, so particles aren't points, they're fuzz or maybe fluid. Universes split infinitely. Reality depends on who's looking and maybe changes the past. There are spooky instant connections. After all this, why can't they just draw me a picture, show me what's happening, show me the split, show me the fluid?
Yeah, that's the natural reaction. But standard quantum mechanics, it's
Yeah.
different from classical physics in that way. One source calls it a principle theory, a bit like thermodynamics.
How so?
It gives you the rules,
Yeah.
principles. Incredibly accurate predictions, tells you the constraints on what can happen, the probabilities.
Right, it gets the answers right in experiments, but it doesn't tell you how it gets there.
Exactly. It doesn't provide that microscopic spatiotemporal picture. It doesn't show you the movie of what's actually physically happening step by step at the smallest level. It explains why the interference pattern looks like it does in the double slit experiment, predicts it perfectly. But it won't tell you how one specific electron physically traveled from A to B.
That is so unsatisfying. It's like having a magic recipe that always works, but you have zero idea why the ingredients do what they do. You just know the cake comes out right.
It is unsatisfying from that perspective. Unlike classical mechanics where you could picture planets orbiting like clockwork or atoms like tiny solar systems, even if those pictures weren't quite right either. Quantum mechanics just doesn't offer that easy visual intuition. Those pictures in textbooks, electron clouds, they're just visual aids for the math, not pictures of a thing doing a thing.
And I guess that's why there are all these different interpretations we've been talking about. Many worlds, console people trying to fill in the blanks because the basic theory doesn't give a picture.
Precisely. The core math works for everyone. But physicists invent these different stories, these interpretations, to try and make sense of what the math means in terms of reality. Some theories, like objective collapse theories, even try to add a physical collapse mechanism to the math, something that forces an outcome.
Did they work?
They face their own challenges. Like, what exactly is this collapse? How does it happen? And you get weird conceptual issues, like empty tails of the wave function bits that supposedly don't collapse but just fade away. It's still not a clear picture.
Okay, so after all this, particles aren't points, infinite splitting universes, reality depends on me looking, maybe changing the past, spooky connections, and physics can't even draw it. It really does start to sound like some of those wilder ideas you hear kicked around online. For real.
And this is where the actual science we've discussed, weird as it is, provides a kind of legitimate foundation or at least conceptual space for some truly reality-shattering possibilities.
Like the simulation hypothesis. We're living in a computer simulation. If reality is just math, wave functions, probabilities, information,
Yeah.
isn't that exactly what a computer could run?
It's an intriguing connection. The sources do touch on simulating universes, how things like entanglement might relate to information compression needed for it.
Right.
And yeah, the really unsettling thought, if we could simulate a universe perfectly down to the last quantum detail, and maybe we could simulate conscious beings, what's the difference between them and us?
Right. And wasn't there something about an incompleteness theorem for the universe? Like,
Mhm.
maybe we can't fully grasp it from inside. Maybe the system running the simulation is necessarily outside.
That was mentioned, yeah. Suggesting maybe the ultimate nature of reality is beyond the grasp of any intelligence within it. A philosophical leap, but rooted in the weirdness.
And quantum immortality. If many worlds is true and all outcomes happen, does my consciousness just follow the path where I don't die, experiencing only the branches where I survive?
That's a direct, if mind-bending implication discussed in relation to MWI. If all possibilities occur and awareness continues along some path, then from your subjective viewpoint, you'd always find yourself on a surviving branch. You'd seem immortal to yourself.
Yep.
Wild.
Totally wild. And what about that really jarring idea? As far as I'm concerned, I'm the only one who's real and you're all just constructs.
Yeah.
That sounds exactly like the consciousness-only solution taken to its logical, creepy extreme.
It does. If reality is fundamentally perspectival, relative only to the observer,
Yeah.
it opens the door to that kind of extreme solipsism, questioning if anything outside your own experience is independently real.
Okay, and one last one. The idea that matter itself is heading towards being self-aware. That we're just the first step, like organelles arranging other matter into consciousness, eventually forming some giant cosmic being. Does any of this physics make that seem less out there?
Well, if reality is fundamentally about information, interaction, and maybe even perspective, it perhaps makes the emergence of consciousness on larger scales seem less fantastical. If the universe is based on these weird quantum rules, maybe consciousness isn't just a fluke of biology on Earth, but a more fundamental potential of how matter organizes itself. These theories definitely frame humans differently, maybe not the pinnacle, but a stage.
Wow.
So yeah, these scientific theories, they really do shatter our everyday reality. They show that based on physics itself, the universe is far stranger, more relative, maybe more interconnected than we ever imagine. They don't prove simulations or cosmic beings are real, but they make the concepts fit surprisingly well with the deepest physics we know.
Phew. Okay. My reality. Thoroughly and, yeah, delightfully shattered. Particles that aren't points, maybe infinite me's, reality warping around my perspective. It's clear the universe is just profoundly weirder than it looks.
It's a good reminder, I think, that the biggest questions about existence, they're still wide open, and the search for answers takes us to some truly unexpected, bizarre places.
It really makes you wonder, doesn't it?
Yeah.
If reality is this weird, this fluid, this dependent on observation, could we, like, collectively, or through future science, I don't know, choose our branch, or even change the rules of the game?
That's a fascinating thought to end on. Where could it lead?
Well, thanks for joining us on this very deep dive into the cool, weird, and possible.
And if you found this reality-shattering discussion as stimulating as we did,
Please do take a moment to subscribe to our channel. We'd really appreciate it.
we'll be back soon with another look at the cool, weird, and possible.